All right, guys, welcome to the Metron Apache community meeting. So we're demoing some of the stuff that's been done in the community for the last couple of weeks. Either already been checked into master or is sitting in a pull request waiting to be reviewed, and will be checked into master shortly. So our plan is to send up the new build to the Apache incubator either Monday or Tuesday of next week. So most of the stuff you're seeing here will go into the next build. And with that, go ahead, Mike.
Okay, so what I'm going to demo today is some new functionality that we've added to the PCAP CLI for querying and filtering the PCAP data that we have stored in the sequence files in HDFS. So previously, what we had was a little bit of a potential performance and memory problem, which was if you have a large amount of PCAP data and you end up running a query that returns a very large quantity of that PCAP data, which there very well might be, it was streaming back through one file on the client side. And so what you'd easily run into in that case was out-of-memory problems. So there's actually a couple of features that really got built here. One was contributed by Casey Stella, which was the enabling multiple reducers with the MapReduce job that runs. But in addition to that, what we've enabled is the ability for the user to specify a paging number of records per page, basically. So what ends up happening is when we run this query, the filter will return back, of course, the filter results. But now what you have the ability to do is specify the number of results per file that are going to get written out. So what this ends up doing is allows you to iterate over the files in a way that's not going to cause the client to run out of memory. So I'm going to demonstrate that now. So actually, let me get rid of this data that I have here at the moment. Okay. So I do have, let's do this. So I've already pre-populated some of the PCAP data in the system just so I can get to nuts and bolts of this and run the query. So what I'm going to do here is run one of the Stellar functions, or the ability to run the query filter results. So what this is doing, the new option here is basically results per file. And so what I've done here is specified 500 because I want to be able to, again, for demo purposes, I don't have a large amount of data here stored in HDFS, but this will basically illustrate how we're able to page the results. So that should be just a moment for that to run. So just a little bit of background discussion about the architectural approach here. For those unfamiliar, the way we end up populating PCAP data in the system is through a custom Kafka spout that we've written where we basically bypass the need to write out to do an extra or additional network hop across the network for a bolt. So what this ends up doing is this customized Kafka spout and Storm allows you to write out to HDFS as a series of sequence files. So it's very, very, very fast. And so basically the sequence files are written out to disk in HDFS, and this query ends up being able to read out then and filter out the results and return them back to you locally. And so from that point, then you can basically pull your PCAP file into another program, for instance, like Wireshark, and view your data there and do additional searching and analysis of the data at that point.
いや、今もうデモしてる。あ、俺喋っちゃった。
Yay, live demo, and it worked. So what I have here is a couple files. What I'm going to do is I'm going to transfer these over to my local machine so I can open them up in Wireshark. And you'll be able to see that, again, I had specified results per file is going to be 500. Again, not a lot of data here, but you'll be able to get to see what we're dealing with. So So transferred over these files. So the first file, let me do it like this. I'm just going to open this up in Wireshark. So the first thing, if you can read here at the bottom, notice that this first file here has 500 packets. Oh, wait, hold on one second. Got to share out a little bit more of the screen. How do I do that? Oh, there we go. Guys see that?
Yes.
All right. So at the bottom here, you can see that the packets are 500. So basically, again, we've specified the number of packets max that we want per file. By default, I have it set to 10,000. Of course, this is configurable, optional configuration that you can specify in the command line when you're running your query. If I open up the second file, as you would expect, and I will reshare that again. As you would expect, there are fewer records in this file. A grand total of 595 records were returned. And so, again, as you expect in the final file or the last file, that there's going to be less than or equal to 500 because of the cutoff point. So that's really the added functionality and feature that we have there. Kind of expands the usability around the PCAP CLI and being able to filter out your results when doing analysis with PCAP. Does anybody have any questions about this? Going once, going twice. Okay. Well, thank you guys for listening. I'm going to pass it back.
All right, thanks, Mike. Casey, you wanna go next?
Sure. Hi, everybody. I'm Casey. Okay. So I'm going to show you, I'm going to continue the theme of showing you stuff on the terminal. And I'm going to show you a little bit of fun that's been done in the last week or so around a REPL for the Stellar transformation language that we use throughout Metron. So it became evident that Stellar was fairly powerful, but it was also evident that it was really hard and unsafe to use in its current incarnation, in the sense that you have to have a valid Stellar statement. And we found ourselves testing Stellar statements by spinning up unit tests or by running, which of course is disconnected from your actual data, or by running them inside of, by pushing them to Zookeeper and running data through them, which is very dangerous. So it became evident that the way to do that is by a REPL. So Nick Allen did a fantastic job of creating a first cut with very simple MVP. It was literally just a REPL. I took it and and made it into more of a management shell almost, but for Stellar. So that's in master now, and I'll show you that. So you can run normal things like normal Stellar statements. There's the notion of autocomplete. I hit tab. You can see it tab completes all the way through. Okay, so you can also do things like reverse search, right? You can get a list of the variables that are currently there. So I can actually assign variables. See, that's updated. And you also see that it captures the Stellar statement that was used to create the variable. You can, so I've been working recently on a set of management functions and a set of Stellar functions that will actually interact with the shell. The management functions are around managing the configs, adding Stellar transformations at all the different places where you can use Stellar in the platform. And those are Stellar field transformations in the parsing phase, Stellar enrichment. There's a Stellar enrichment adapter, so specifying Stellar statements using for enrichment. The threat triage is a Stellar rule associated with a number. And also managing the configs, pulling them down, pushing them up, things like that. As well as a few kind of candy type things where we can visualize things a little bit easier. Like for instance, if you didn't want to look at that just list here, it'll print out in the table, right? Okay, so let's get through I'm going to go through my normal demo, but except I'm going to do everything in Stellar. So my normal demo is I want to add I have a model that's deployed out using Model as a Service, and what I want to do is I want to interact with it, right? I want to tag messages from the squid parser with the output of my model, right? I have a DGA model, a very simple DGA model. The DGA model thinks everything other than Yahoo is malicious. So if you're yahoo.com, you're legit. Other than that, you're malicious. Right, really, really simple, right? Okay, so first thing I'm going to do is I'm going to pull the configs down. Okay, you notice I'm looking back in my history. That history, by the way, spans instances of Stellar, of the Stellar REPL. Okay, so I'm going to pull down my config. Let's look at the transformations that we currently have in them. So we can do that with parser Stellar transform, and then it's print. But I kind of forgot how that works, so I'm going to look at the docs for that function. And you can see the docs there. So it just takes us the sensor config. Okay. So by the way, this is using a proper read line. So if you I've modified my .input.rc to use vi mode. So you can bounce around the normal way you interact with any shell. So parse config, and we have two functions here associating full host name with URL to host and domain without subdomain. So that's the default squid, right? I want to modify that. So first thing I want to do is I want to figure out how to run my Model as a Service. All right. So I'm gonna kind of load this up, but Model as a Service, I'm gonna call it to the model. I'm gonna grab the endpoint from Zookeeper. I may have multiple instances of the DGA model on Zookeeper, and it takes one argument, the host. I'm gonna return that back. That's kind of ugly. Let's look at it in an easier way. Nice and pretty. So it returns a map where the key is malicious and the value is malicious or legit. All right, so you notice I am referring to domain without subdomains. Notice it auto-completes variable names too. So that's CNN. If I subdomains, if I specify it to be Yahoo and I run that again, you notice it's legit. Okay, so it's really calling out to the model. So now that I have the domain without subdomains, or rather I know what function to call. I'm going to call is malicious, but I actually just want the value malicious legit. Actually, let's call it DGA output. I'll call map get and the output of that. Okay, and that's legit. So that's what I actually want to use. So I'm going to call parser add. I forgot how that works, so I'm going to look at the docs. Okay, So I'm going to pass in my sensor config from before. And I'm going to pass in the stellar. So the stellar transformations is a map associating fields to stellar expressions. Well, I have a shell function here that will allow me to take a set of variables, in this case DGA output, and return a map with the variable name associated with the stellar expression that created it. So that's going to return me back, and it returns back the config in Zookeeper, but I don't want to look at that. I care more about parser. Look at the print. And you'll notice that in addition to my domain without subdomains and full host name, I now have DGA output. And it's associated with my nice function here. Okay. So I'm going to save that off into a new variable. It's called squid parser config new. Okay, and I'm actually going to go ahead and push it using config put. So I'm gonna replace this in Zookeeper. I'm gonna replace the config in Zookeeper with the new config that I've created here. I'm going to, so the type is parser. The config is squid parser config new, and the sensor is squid. Okay. All right. So just to validate that I actually did that right, let's pull the config. Zookeeper. And you see DGA output is there. Okay, great. So what we're going to do, but that's not very useful. What I want to do is percolate this all the way through into my threat triage, right? So now I need to interact with the enrichment. Squid enrichment config, so let's grab that guy. Pull from the enrichment. So let's, oops. I'm going to print this guy, so remember how this guy functions. It takes the config and it takes the type. Do I have any current enrichments? Nope. And do I have any threat intel? Nope. So as you recall, the architecture of the enrichment topology is there's two phases. There's the enrichment phase and the threat intel phase. And at the end of the threat intel phase, we do threat triage. So what we're going to do is we're going to add a new function here. So we're going to say is malicious, and I want to specify it's malicious if the DGA output is malicious. Otherwise, I want it to be false. Right? So is malicious is going to be true if it's malicious and false otherwise. So I'm going to add that guy. Oops. I'm going to do enrichment, stellar transform, add, and then let's see, forget how it works. Let's just verify. Okay, so it takes the config. And I'm gonna add it to the threat intel phase. And it's a map associating the fields to the stellar expressions. So I'm going to be able to use the same thing I did from before. And it is the malicious. Is malicious. Except, all right. So I created that. So let's just verify that the print Oops. So you'll notice I passed in the old config. I'm going to pass in the new, and you'll see that there's a field called is malicious, and it's associated with that transformation function. Okay. So now I have the new. So, but in order to use it in the alerts, I have to specify is alert, which is a special, it's just a special field. So is alert has to be set to true, otherwise it won't run the threat triage rules. So I want to add another one, and I want to say is alert is true if is malicious. If is malicious, then true. Else is alert. All right. I don't want clobber is alerts because it could be I could have other alerting set on. All right. Okay. So I'm going to do the same thing I did from before. Except I'm going to add it to the new one, and I'm going to add as alert. Okay. So now that I have that, I'm actually going to add another enrichment. So I have loaded some, I followed the blog posts, and I added some WHOIS data into HBase. So I want to grab the WHOIS data, so it's going to reach out to HBase. And that looks very ugly. That looks a lot nicer. So Yahoo, turns out, owner's Yahoo Inc. So I got my WHOIS data. So what I want to do is I want to add all of this data into the message, and I want to unfold it in the map. Oops. Sorry, good mode got crazy on me. Oops, kill the shell. Sorry about that. Okay, so I modified some of the configs, but I didn't get all the way through them. All in 1 second, just bear with me. So one thing you'll notice when you start up Stellar, it actually loads from the class path. So all you have to do if you add new Stellar functions is drop a jar file in the lib directory. So that's all I've done here. You don't have to build, you just have to build against Metron Common, but you don't have to incorporate, you don't have to pull Metron Common into your jar. It's a runtime dependency. Okay. Oops. Okay, so oops. Okay. Okay. So is malicious is that, is alerts that. I grabbed that dude. This should bring us back to where we were. Just gonna add those two guys. Oops. Sorry. Okay. All right, so I have my two messages in there, just like I did before. Okay. Sorry about that. Everything should be back to normal. So I'm going to create a variable called whoisinfo, and it's just going to be grabbing from that table. Oops. If I can spell enrichments. There we go. All right, so just like I added to the thread intel portion, I'm going to add whoisinfo to the enrichment portion. Okay, so now that's what's in thread intel. That's what's in enrichment. What I also want to do is add to threat triage. I want to add a threat triage rule so that if my if is malicious is true, then I bump the alert, the triage level up to 50. Okay. So I'm going to add that here. So I'm going to modify the config. Okay. Oops. So I'm going to print it out. And you can see is malicious is 50 with aggregation of max. That's the rule. Okay. So now I have enough so that I'm comfortable putting the config. I'm going to put it in enrichment. Oops. And I have to specify the sensor type. So that should be put in. I put the data in there. So now the topology is running, so I shouldn't have to replay it. I shouldn't have to do anything other than just add data. So I'm gonna send two messages for my access logs, one where I went to Yahoo and one where I went to CNN to the squid topic. Then we're gonna pop over here and look at the head plugin. Oops. All right. So the problem is the index is unset. Okay. Well, that's easily fixed. We'll take a look at it anyway since it's already passed through. Small bug there. Problems with it with any live demo. So you'll see that as I went to CNN, is malicious is set to true because of my DGA model. The triage level is set to 50. And because it's claiming to be malicious, and you can see that it has some whois information on there attached. All right, so I'll stop here and see if there's any questions. Stop sharing.
Casey, there's a couple of questions on in the chat.
Yep. Okay. The current HBase enrichment sees will be taking a key and then making a hash and turning it into bytes. Then it uses that to get the row key and enrichment back. Is this REPL using the same method, or is it retrieving the row key in the same format and being put into HBase? Yes, it is. So it's using exactly the same methods for. So the normal ways that you're running that you ingest data into HBase will work with the REPL, the enrichment _ get. This the stellar function. Yeah. So anything else? Any other questions? So the management portion of this is still in development. As you saw, there are a couple of bugs here and there. That'll probably be in, I expect, next week. So what if I don't want the transformation? Is there any way to avoid the transformation from occurring? I don't think I understand the question. If you don't want to do a transformation, then you don't have to specify the transformation. Or do you, oh, you mean in HBase?
Hey, can you hear me?
I can hear you.
Okay, cool. So I just have a general question. So we were doing some HBase enrichment, and in our situation, we are populating the HBase not via Metron. So we're doing a different method to populate HBase, and then we want to take what's an HBase and send it and make an enrichment. But the way that it's coded right now, you assume that you're dumping into HBase via whatever format Metron wants to do it in. So it ends up doing this transformation to dump it in, and then to retrieve it, it's looking for the transformation again. The issue is that if I already have HBase dumped, and I just want to retrieve the information, it's now looking for the hash and then the byte conversion.
Yep.
And so what I'm asking essentially is, now I have an alternative way of dumping into HBase. In this case, I am doing it on my own and not via Metron. Will the REPL allow me to kind of avoid having to deal with how the Metron lookup is checking for that byte and hash?
Yes. So yes, the short answer is yes. The long answer is it requires some coding. Right. What you would need to do, right? So you're not able to do that via enrichment_get, because enrichment_get is assuming that you're putting data into Metron the way that we load data into Metron via our external entities, right? But what you would do is you would create your own function called HBaseGet or whatever your namespace you want to call it, right? If there's something special in the key structure. And so what it would do, what all you do is you specify. It's actually I'll show you. I'll share my screen again if you don't mind. I'll show you what a stellar function looks like, just real quick. So let's take a look at a really simple one. The anatomy of a stellar function is as follows. You specify an annotation like this. This is my var to map method here, and it implements an interface. There's a couple of methods on the interface: apply, initialize, and a boolean that says it is initialized. So what you would do inside of that is, and I would suggest you look at the implementation for enrichment get as an example of how to reach out to HBase. But what you would do is you would write, you essentially create a stellar function, call whatever you want, and then as long as that's on the class path, you can refer to it from within your enrichments. So when I say it's on the class path, I mean on the shell, you just have to drop it into the Metron home/lib directory. But if you're doing it on a running cluster, you have to modify storm.class path to point to the location of your jar. And that jar has to be on every node that's running a supervisor right now. Does that make sense? So the idea is that Stellar is extensible, is the point of extensibility in the system.
Okay. All right. Thanks for the answer.
No worries. And if you need any help with that, please post on the dev list. I mean, any number of people will be happy to help you out.
Awesome. Thanks.
Any other questions?
All right, Casey. Thanks for that demo. Let's see, guys. You want to do the Ambari piece next?
Yeah, I can go ahead and do that.
Yeah, let's do that.
Hey, I'm Justin Lee. There's been a bit of discussion on the dev list, so some of you have probably seen that, about basically easing the Metron installation process, exposing a lot of the configs, making life a lot easier than it is right now, because that's been one of the common pain points. So there's a PR right now for a very MVP implementation of Ambari management packs for Metron. So if you're not familiar with the management packs in Ambari, it's a feature in 2.4 that basically allows you to bundle up a service and install it in Ambari without having to be rolled into the actual explicit stack that you install. So you can basically take services and install them on top of existing stacks and kind of plug in what you want. So we've basically taken indexing, parsers, and enrichment, along with a couple supplemental things like spinning up an Elasticsearch and Kibana, and rolled them into a management pack that you can basically just throw onto a cluster and then actually start to put it separately. So why don't I share my screen? So I have an existing cluster. This is running on Docker, so memory is pretty limited. So you can tell I've just killed a couple things just so that they don't take up any of my valuable memory. I'm also running a separate Elasticsearch, just again, so that I'm not cramming everything into a bunch of fairly, modest Docker, since I'm just running this on my local machine. But we're basically going to just take that MPack, install it, and then actually just run through the install process in Ambari. And then we're just going to go to the command line and just inject a couple copies of some messages into one of the topics for parsing and carry it through to Elasticsearch. So the boundaries of the MVP are essentially post sensors. We, basically from Kafka, and then getting it, parsed, whatever enrichments we have. In this case, we can preload GeoIP and then pass it through to Elasticsearch, either internal or external. So in this case, we're going to be providing the configurations for the external Elasticsearch. That's also just running in another Docker container. Any questions about that before I kind of dive into the actual install process, just to make sure, given that the management pack stuff is kind of new for Ambari, just make sure we're on a common ground before we start talking. And can I actually see chat? So give a couple seconds if anybody wants to say anything. Apparently we're really excited about Docker, which is good. So I'm gonna just dig right in then. I have this a little more scripted than Casey, just because I can't remember things as well as Casey does. Basically just have a lot of the commands scripted out, more command line for everybody. So I'm sitting on the Ambari server node right now. Basically, we want to install an MPack. Let's just call out to Ambari server, install MPack. I just have the MPack mounted on just in/MPack. That is actually just a clean install from Metron deployment. We'll just produce the MPack in a target folder, and that's just linked up. The other thing we have linked up is local repo. So if you've seen the RPMs, these can be generated locally. There is not a remote store for our RPMs yet. So you will have to build them and link them locally. Specifically in/local repo is where we look. So this is like documented in a README that goes along with a pull request. We just say verbose, and then force is if you've already installed the MPack. I didn't really need it here because I haven't installed the MPack yet, but it just runs through, gives you the information you need. Our MPack installed successfully, and we're going to restart Ambari server just to pick up these changes. So we'll give it a minute, go back into Ambari, and be able to take a look at the services just kind of through the normal add service process. So this and actually installing the service are the super exciting parts of the demo, where we watch bars fill up, which I know everybody loves in a demo. So kind of as some side notes, there are some caveats you'll see as we kind of pull up with this. This is pretty MVP, like I said, so there's kind of a list of things that we kind of need improvement on. So just some general things where, getting Ambari to kind of line up with some configs, like for instance, we have to enter in a storm config in here, even though we should be able to interrogate Ambari for that. Let Ambari find everything real quick here before we actually go through. Couple other caveats like that. Again, they're detailed in the README. There's been a discussion on the news group. And the actual ticket itself, which I cannot recall the number for, it's like 473 maybe. If you want to take a look at that. So everything's up. Ad service, we come through here and we have Metron and like Elasticsearch and Kibana, which we're not going to deal with right now because we have the separate stuff. 427, I was close. Thanks, David. So we can just click through and install it. I'm just going to put it all on 4, mostly because I already have the IPs lined up for 4 for being able to hit this stuff. Given that it's on Docker, it doesn't actually matter. It's using the same memory pool for everything. So we need a couple configurations, which I'm just going to pull because I've already cheated and know them. So specifically, we are providing the Elasticsearch binary URL and port. So this is just that Docker container we're running. Whatever the database is for password for enrichment, whatever you want to set it to. And then, like I said before, kind of one of those caveats is we need the storm rest URL, even though that's something, you know, theoretically we should be able to grab from Mbari. We hit next. That's not related to our stuff, so I'm hitting next through it. Deploy, and we will actually start to spin these up. Probably doesn't help that I wish I had killed the snort and yaf topologies. Specifically, I'm just going to run bro. I'm actually probably just going to see if I can piss my demo off under the hood and just kill those in Storm. Rather than run through the whole restart process. Just takes a couple minutes and it's just a little bit of extra time. Nobody wants to watch bars fill up. Again, that's just more a memory concern rather than everything else. The more workers I'm spinning up, the less happy everything is on here. I can try running it, I guess, and we'll see if it crashes everything. But that'd kind of be doing it a little more live than I'm sure everybody wants to watch. So this Docker instance is actually kind of pre-built. So my README actually lists out, I believe, what I'm grabbing. But yeah, it's running console in conjunction with it to manage this. We'll kill that. And again, it's just running through the standard process, installing all the components. It'll start them up. And again, this is another thrilling part of the demo where we watch bars fill up. After that, we'll just go kind of inject a couple messages, make sure things come through. We're just doing that for Docker. This is just entirely stuff that's already pre-built to spin up a cluster in an easy manner for us. I didn't like manually build out like this cluster. We're basically just spinning up a cluster that spins up like 4 nodes in Docker plus the Mbari server, and then just running a blueprint on here to actually like set it up. So that's not something that we really did as part of this. That's pre-existing stuff. Any other questions while we're running through the probably best time to ask questions we have here?
Hey, Justin, so how far away are we from being able to use a Docker setup like this for development versus the Vagrant nodes that we have today?
We'd probably, there's probably actually, it's probably a good topic of discussion for the user group. Like the user list, there's been a bit of discussion. I know Otto touched on some of this, kind of how these interact. He talked more about the Ansible relation to it, but I don't know if there's been any discussion, somebody else can correct me if I'm wrong, about replacing the Vagrant stuff with Docker at all. This was just more because it's easy to just spin up a relatively clean HTTP cluster. And that's just because it's easy to spin up with Mbari.
Yeah, it doesn't have to replace Vagrant. It'd be a heck of a lot easier to run Docker to do development than it would be with Vagrant. I can barely do multiple things at a time when I've got Metron running on Vagrant on my laptop.
Yeah, so I think that's kind of been a pain point for some people. Like I said, that's probably a great discussion to start on the like dev or user list. If that's been a kind of point of contention for you being able to develop in an easy manner, and I know like I've hit some of the same issues too. That's something that, I think we could get a good discussion around and steer in, whatever way works best for everyone. And we're mostly starting stuff up at this point, so a couple more seconds. This is just kicking up all the topologies and so on, making sure that they're actually running, so it just takes a few seconds for everything to be happy with the state that it's at. Let's get that. If anybody knows enough about Mbari to speed this process up, they would absolutely be my hero. Right now, it's a necessary evil. Like I said, it's pretty MVP. This is a really good spot if you have any knowledge or interest in making everybody's life easier to actually kind of hop in, learn things, and contribute. Like I said, given that it's an MVP, it's pretty early stuff. It's not really super complicated. The code's, relatively easy to look through. It's fairly organized. And I would absolutely love people to contribute to this.
Do you have any kind of pointers on really good points or really areas are a bit weak that would be ripe for contributions?
Yeah, so that's actually one of the things that if you look in the user group, there's like, or actually even in the README on the pull request, there's like a list of, I think 6 or 7 things that are kind of things that we should, are pretty obvious candidates for being improved. So like I said, things like pre-populating the configs, allowing the use of an external MySQL instance, just kind of other things like that. And then on top of that, I'm sure everybody's going to have opinions on how we build on top of this in the future. So that's absolutely something I expect to get discussed on the lists, and there's going to be plenty of work to do there. And unfortunately, I have tried downloading more RAM, and it turns out that makes your computer even slower once a bunch of programs you don't recognize start. So indexing should be the last one. This is one of the reasons I actually wanted to kick out the the snort and YAF parsers, just because the more topologies you're spinning up, the more work there is to do in the background for things. And then the check should go actually pretty quick once this is done. So actually starting topology. Should have given my VM even more RAM, clearly. This is that watched pot thing. Now that we've got, 20 people watching this, it will never boil.
How much RAM are you giving your Docker machine out of curiosity for those of us looking to develop on that?
8 gigabytes, and clearly you might want to go a little larger. So, okay, here we go. So things reload, and we have a Metron service with the various stuff running here. If we go take a look on our Storm UI, we have all of our various topologies running. So our parsers, indexing, enrichment, pretty much what we expect. So if we head over here and I have this in the way, we're gonna, not what I wanted to open, but of course I opened it anyway. But actually I have to install the template real quick. So there are some Elasticsearch templates. These are just an action after this, because we can't really guarantee that if you have an external Elasticsearch that it's up, but if somebody wants to improve that, this is absolutely a good area to improve upon. So this will just go install the appropriate templates for our services. And so we want to actually push some data through to our topic. We'll just push a couple copies of this. And if we pull from beginning, we should actually see that this went through to the bro topic. All right, so 5 messages. And if we look at indexing, hopefully, not doing this too quick, we see a few messages. And now I need to figure out how to make this actually hide. If somebody knows the answer, that would be delightful. Is there a way to hide that? Or if somebody knows the key commands to actually shift tabs, that would be delightful also. Can I? Of course not. All right, well, we're gonna. Right, and so we have 5 hits in our Elasticsearch and various all the stuff. Enrichments, you know, pretty much what we expect from Elasticsearch. So everything made it all the way through and is then available in our index. Any questions? All right, then I don't see anything in chat either, so I will pass that back to you, James, or who's ever going next.
All right, thanks, thanks, Justin. I think the last piece that we wanted to demo was the profiler. I think Nick was going to do it. All right, Nick, floor is yours.
Okay, guys, so this is Nick. We've only got about 5 minutes. So I'm going to try to walk through it as quickly as possible.
This is being recorded, so take your time, Nick.
Okay. So what we have here, what I'm going to talk to today is the profiler. If you go under Metron Analytics, Metron Profiler, that's the core engine that does this. So the profiler itself is a feature extraction mechanism. So, think about Metron. We've got lots and lots of data coming through, streaming constantly. How do we take that data and get it in a form that we can actually start to use and build some statistical models, do some machine learning? How do we actually kind of get some concrete data that we can start working with? So that really is what the profiler was meant to solve. So with the profiler, what you do is you define with a number of these fields, and I should say that a number of these fields are use Stellar themselves. So this is kind of another touch point for Stellar. And I'll go through some examples just because that'll probably make it much more real for someone. So imagine that we have this data coming in. It looks like these messages here, right? So we have a source address, we've got a protocol, we've got some random field length and bytes in. So this is just streaming in. We're trying to make sense of this data and use it for something, you know, halfway decent. So I could define a profile. I define this profile here. It's just called example one.
Can you make the window a little bit larger?
Sure. How's that?
Maybe 2 sizes larger would be better.
Oh.
There we go. Thank you.
Okay, I can take my glasses. All right, so we have the profile called example one. And so what we're going to do is create a profile for each IP source address. So for every message that comes in, we can see in this example set here, we've got 3 different IP addresses. So we're going to have a profile for each one of these IPs. And in generating the profile, only if the message itself has a protocol field that equals HTTP. So, you know, we have lots of different data streaming into Metron. So we need to be able to kind of whittle that down to just the information that you want to profile. So in this case, you know, I'm only looking at HTTP information versus, say, DNS or secure HTTP. You have an init field, so basically you define variables. You can say, okay, I have this field called total bytes. I'm going to initialize it to 0. And now every time I get a message that passes this conditional, I'm going to update a variable called total bytes, and I'm just going to add the previous value to the bytes in from that particular message, right? So I'm seeing this, and I'm adding this field up as the message is coming in. The profiler basically is using a sliding window type mechanism. So we're accumulating data over a period of time. And then after the window expires, we're flushing the data to disk. So we've updated this variable total bytes over time. At the end of that window, the time period expires, we need to flush. The result of this is gonna be total bytes. So this is the value that we're actually going to persist that we can then use to do statistical modeling and start to really use. There's also some other functionality in terms of how long that data will live. So you can also specify an expiration. So you can say it expires after 30 days in this case. Many of these fields are optional. So it doesn't always have to, you don't always have to define an expires or even a conditional. And a lot of that is defined in the documentation. I have it all linked here. Really, so there in that example, right, we're accumulating the total number of bytes. Does that kind of make sense? So we're looking at the HTTP data coming in, and we want to accumulate the total number of bytes over each time window and persist that. Now, over time, you know, once one window period expires, of course, another window period starts, we start accumulating, we write to disk. So once you've done that many times, right, you've got a time series. So for this profile and for each IP source address, we're going to have a single time series that tells us, you know, some aspect of what that IP does, the view into the data flowing through for that IP. You can do other type of things. So in this case, I'm going to look at the ratio of DNS traffic to HTTP traffic for each host. So it's very similar. I'm going to say for each IP source address, I only care about DNS and HTTP traffic. I have my counters, and I add to my counters. If the protocol is DNS, then I'm adding 1, else 0. And at the end, in this case, I'm doing an operation on the result. And it's that ratio. So it's the number of DNS over the number of HTTP, and then I store that record. Another example is using the stats package that we've created kind of at the same time as building out the profiler itself are these stats operations in Stellar. So what I can do is say, okay, for each IP source address, only if it's HTTP, I want to add the length field to my stats package, and I'm accumulating that value. So now I'm going to have a bunch of basically accumulated record of each of those length fields. And then when I'm done, I can call various different types of summarizations of that data. So in this case, I'm just calling stats mean. You could call stats percentile and figure out, say, the 90th percentile. There's lots of different operations you could do. And I think the stats package kind of makes it a lot easier to do those kinds of things. Notice how simple this is compared to, doing this kind of ratio, or if I was doing an average manually, I'd have to have a sum variable, an account variable, and divide those at the end. So that stats package really kind of goes well with the profile to make it easier to use. Is that making sense so far? Any questions on kind of the core purpose of the profiler, what it's supposed to do, what problem it's solving?
This looks good. I will put a quick pitch about the stats package. So it recently was augmented. So you can actually store the statistical objects themselves and refer to them later. So instead of just storing the mean, you can store you could have had result BS. And because we store at the 15-minute tick or at some duration, you can take those stats objects, merge them together, and ask questions about the statistics of the merged objects. So if you can you can essentially accumulate a statistics object about the last hour by merging the stats objects for each of the 15 minutes increments. And under the hood, that's O of 1 memory. It's using a T-digest to store which is a probabilistic sketching algorithm to store the percentiles. So it's just a quick pitch about that.
Maybe we can do a demo on that on a later day. That's a whole another topic. But yeah, it's very useful. So here, let's go through actually using it. So right now, I've got YAF data coming in. I've got my PCAP data being replayed on a Vagrant node. I've got my YAF parser running. It's parsing that data. So now what I've done is I'm on my host, and I'm going to look at the configuration for the profiler. So right now I have 15-minute periods.
Nick, the font is too small again.
So we have 15-minute periods. We're going to store data in a table called profiler. You can define the column family. Other settings in here in terms of HBase flushing and things like that, not that interesting right now until you dig into it. So what I'm going to do is go ahead and start the profiler. So I'm going to say start profiler. And so while that starts, and make sure that everything is happy. So we've got that YAF parser. He is dumping data. He's parsing that YAF data that's hitting the YAF topic. It's dumping it out to the enrichments topic. So let's just make sure that that's working. There we go. So we've got that parse YAF data coming in. And right now I just have it set, I think it's still set out of the box in Metron when you install to cut a flow each time a packet comes in. So really, these aren't real flows. These are single packet flows. Not that useful in real life, but useful for testing this sort of thing. So now I have the profiler, data ready for the profiler. Now let's check on the profiler. Profiler runs as its own topology. It's got 3 pieces. So you've got a Kafka spout, so it's pulling data. I told it to pull from the enrichment. This then hits a splitter bolt. So this guy is consuming all the data. He is looking, taking that field of data and taking that conditional that you specified here. There's only if. Right? So that splitter is actually doing this logic here to only let the messages that we care about through into the rest of the topology. He then splits it out based on profile and entity. So, you may define many profiles, and a profile may have many different entities within it, think many different IP addresses. So there's actually a separate bolt instance for each profile entity pair. So that splitter is directing that message to the right builder bolt based on that entity and the profile name. So some of that logic that you've defined in the configuration is occurring here. The data is then accumulated in the builder bolt. It runs the rest of the logic, say the init and the update logic. It also uses a tick tuple from Storm. When that 15-minute window expires, it gets that tick tuple. It has that data in memory, and it'll run your result operation. So like a stats mean, it'll calculate that mean. From there, that data is then pushed as a message to an HBase builder. So you've got many different builders here. They all potentially have their own schedule in terms of when they're expiring or not. It's not going to be exactly at 15-minute intervals. It's being dumped to this HBase bolt, and this HBase bolt then has its own batching mechanism to be able to do multiple writes to HBase at one time to kind of make that more efficient. So under the hood, that's what the profiler topology is doing. Is that making sense to have any questions? And as you can see, data is coming into the splitter bolt. It's hitting the builder bolt, and then the builder bolt actually hasn't expired yet because we're at 15-minute intervals, so we have to wait 15 minutes for data to actually flush and get sent onto the HBase bolt and get written to HBase. What I have done is look at, or I've preloaded, I had this running for a while, and I loaded some test data in there. Let's go ahead and just kind of look at the raw side of HBase. I'm going to open up the HBase shell. Remember, we defined that table profiler. Let me go ahead and count the fields in here. Yeah, so this shows we have 1,286 records in that table. So, that's how many times a builder has flush with this setup. That's how you can think about it. I think this gets you a good view into the Roki mechanism that the default implementation uses. So first here we have a salt just to help prevent hotspotting when you're running this across a cluster. It then uses the profile name, which in this case was just profile, or profile 1 actually. Then it uses the entity name, so we've got that IP address. And then we use an indicator of the period. So the basic implementation basically cuts up time into discrete periods since the epoch, and then has a kind of monotonically increasing counter that counts each period, and that's what this field is. So really with this key, it's deterministic, right? I know that if I'm looking for data for profile 1 with this IP address at a certain time, I know exactly what this row key should be, and that lets you do the lookup into HBase to get the data back efficiently. That's the ugly side. So now let's go ahead and look at the client piece. So you, in the project, so this was the Metron profiler. You go to Metron Analytics Profiler Client. what we have in here, and there's a README actually in a PR right now that'll get pushed out that has some more information on how to use this side. But we have a Java API and also a Stellar API. I'm going to show you the Stellar API. So really this was the driver. Debugging kind of this setup is what drove the REPL in my mind. It was really hard to figure out what was going on with this function, so that's where it kind of came from. Casey showed this before. It's really nice and easy to use. Right now I'm just waiting for the function resolution piece to finish. Just right now in this version, it searches the entire class path. So I've seen on the server with my overloaded laptop that it takes maybe 20 to 30 seconds. Not something you'd actually experience in production code, but just for this show right now. Okay, and actually I forgot. So to show you this, I need to actually connect to Zookeeper because that'll have my my global configuration that we have defined for Metron. This function that I'm going to show you, profile get, actually needs that to be able to know which HBase to talk to and things like that. Thanks to Casey, I can just hit up and go and see that this is my call. So profile get, I'm looking for profile 1, I'm looking for this particular IP address, and I want the data for the past 30 days. And actually right now the delay is the function resolution again. It's actually really quick. Let me just run it. There we go. So there's the data. Let me just run it again. There you go. It's pretty quick. So you've got that data back, and this is that time series, right, that you can start doing something with. The use case for this client API right now is kind of on the model storing side of the house. So you know, we have the model as a service. We've got Casey's DGA model. I want to feed the data for this IP address so that his model can do the storing for me. That's where you make this kind of call, get your current profile data, and then feed that into Casey's model and get your response back. Yeah, so that's that. I would say, show you real quick, the you can plug in different row key. You can totally plug in different implementations of how you store the data in the persistence tier. So in HBase, I have it broken out. I have a row key builder that's responsible for generating those row keys, and then I have a column builder. The default implementations right now, there's only one for each. You've got the salty row key builder, who actually uses, you know, a salt, that's where the name comes from, to build that row key. And so the client side and the server side both use the implementation classes here, the row key builder and the column builder. So if you wanted to enhance this with your own row key scheme, maybe your environment is slightly different and need something else, you can certainly do that. I think I put that out there just as an FYI. Also here, so column builder defines the columnar structure of the data. So by default, I only care about storing the actual value of the profile, which is why I call it value only column builder. Which, you know, someone else could certainly change that up. Okay. Are there questions?
So I just want to chime in one quick thing. The profile is also really useful in the threat triage rules. So if you're threat triage, you can now do you now have the building blocks to construct rudimentary outlier analysis, right? So with some amount of rudimentary statistical outlier analysis from within Metron itself. So I think this is just really great work. So I think I'm super excited about it.
Yeah, I also wanted to chime in. It's not just the triage rules that you can do, is you can also do massively scalable stateful rules, right? Which is the key thing that we've been
so you can answer questions, exactly. So you can answer questions like, you can bump the rule. So you can bump the alert if that user has had more than 5 snort alerts associated with him in the last 15 minutes or the last 30 minutes or whatever, right? So it opens up the rules engine for some amount of state in a scalable way.
All right, guys. I think this is it. So we've gone over a little bit. So lessons for next time will probably an hour and a half for this. All right. I think this is it for the demos. Any questions, comments until we close the meeting? All right. So I'll stop the recording. If there's any additional questions, this will be posted as a discuss thread on the Metron boards. If you wanted to follow up or ask additional questions, just comment on that thread. All right, guys, thanks for coming. Thanks for